In this video, we're going to solve some logarithmic equations that have different bases. Here we have the log of x to base 2 minus the log of 2x to base 4 is equal to 1. And normally, if the base is the same, we could just use properties of logs and write this as a single log and solve it. But before we get into it, we have that one and this one here. And of course, we want to know for sure definition of log of x to base b equals to L. That's the logarithm. So what is a logarithm? It's an exponent, because this implies that x is equal to b to the L. So L is a logarithm, and you can see it's an exponent here. The base has to be greater than 0, cannot be 1, and x has to be positive. So whatever you take the log of has to be a positive number. X cannot be 0. And then we're going to be using the change of base formula that tells you that if you have the logarithm of any number to any base, you can rewrite it with a different base. So log of x to base b is equivalent to log of x to some other base. You pick the base, log of x to base a, say, and the log of whatever this base is here, in this case it's b, to the base you pick. And normally you pick log to base 10 or base e. That's the natural log, because that's what your calculator has. But there's other ways to do it. And let's go ahead and do this. But I work it one way, and there's other ways, like I said, to do it. So this is base 2 and this is base 4. So what I'm going to do is I'm going to write the first one in terms of base 4. So this would be the same thing as, I can rewrite that first log as the log of x. Any base I want, because this is 4, I'm going to pick 4. And this will be over the log to the same base that I picked, which is 4, of whatever this base is here is 2. And this will be minus. The other one, I'm going to leave it, because now I have the same base. And that's what I'm looking for. Log of 2x to base 4 equal to 1. Now, using the definition of log, the log of 2 to base 4, so let's look at it this way. The log of 2 to base 4 is equal to some logarithm L. So this would be then, by the definition of log, 2 would have to be the same thing as 4 to the L power. So I want the number L that will make this a true statement. So 2 is equal to 4 to what power? Now if you can't see that, you can rewrite it this way and say, well, 4 is the same thing as 2 squared. And that's second to the L power. Power to a power, properties of exponents. You can multiply the exponents, so that would be 2 to the 2L. And because I have the same base, 2L has to equal to the power on the other side. This is 1 to the 1. So 2L has to be 1. Divided by 2 means L has to be 1/2. And you can see that's true, because 4 to the 1/2 means the same thing as the square root of 4, which is 2. So I can just replace this by 1/2. So I have the log of x to base 4 is 1/2. So let's just multiply through by 2 to get rid of the 1/2 in the denominator. That'll give me then, this will become then 2, multiply by 2 log of x to base 4 minus, the other one stays the same, the log of 2x to base 4 equal to 1. And then there's a property of logs that tells you that if you have a number multiplying a log, this coefficient 2 becomes an exponent. So I can move this over here. So this then, I'll write it up here, can be written as the log of x squared to base 4. Leave the other one the same. This will be minus the log 2x to base 4 equal to 1. So now since I have the same base and I have a difference here, property of logs tells me that when I have a difference of logs, I can write it as the log of this quantity over this quantity. This is base 4. So this would just be written as x squared over 2x. And this is still equal to 1. That's the properties of logs. You have a difference of logs, you can write that as a log of a fraction. This value, or this expression, over this expression. Now always be thinking ahead here. The log of x minus the log of 2x. Again, by the definition, we know that this number cannot be 0. Because a log of 0 is not defined. You try to compute the log of 0 on your calculator, it will give you an error. Now, you have the standard log expression, the log of a number, or log of an expression to a base equals to some number. That means that whatever this expression is, in this case x squared over 2x, has to equal to this base 4 taken to that power. 4 to the 1. 4 to the 1 is 4. So I'm just going to multiply here both sides by 2x. So the 2x will cancel on the left side, so that's going to give me x squared. On the right side I have 2x times 4, gives me 8x. Now I have a quadratic equation. So normally I want to solve it by factoring, if it factors. So I bring the 8x over. Same thing as adding minus 8x to both sides. I get minus 8x equal to 0. And factor out an x here. So I'm going to solve this quadratic by factoring. So now once we have the product of two factors, we know that when you have a product of factors that equals to 0, either one of the factors or both factors are equal to 0. So just set each of these equal to 0. We get x can be 0. Or x minus 8 can be 0. So adding 8 to both sides here gives me x equal to 8. Remember, I just said a while ago that x cannot be 0. So if you want to check this, you put a 0 where the x is, you get the log of 0 to base 2 minus the log of 0 to base 4. Again, it doesn't matter because the log of 0, no matter what the base is undefined. So this one we have to reject. And this one should be the solution, but we have to check it. So let's put it in there. Log of 8, let's put an 8 here, an 8 here, and an 8 here where the x is. 2 times 10 will give me 16, so let's check and see if this works. So you're saying the log of 8 to base 2, well, that means 2 to what power gives me 8? Well, it's 3. So the answer there is 3. This one says the log of 16 to base 4 is what? Well, 4 squared is 16, so this should be 2. 3 minus 2 equals to 1. So 8 is your solution. Could you do it another way? Yes, you could rewrite this as the log. If you want to use base 10, be the log of x to base 10. Remember, if I don't put the base, it's understood to be base 10 over the log of 2. Now in this case, since the other one doesn't have base 10, I'd have to do the same thing to that one. So I could rewrite this one as the log of 2x to base 10 over the log of 4 to base 10 equal to 1. And then I would proceed, and then I could also rewrite this. 4 is 2 squared, so again, I can make the 2 a coefficient, and that would be log of 2 to base 10 times 2. Then I would multiply both sides by log 2. And the process would be a little bit different. The equation might look different, but you wind up with the same answer of 8. So again, there is more than one way to solve the problem. Again, notice this is log of x to base 8, log of x minus log of x to base 16. Again, right away we know x cannot be 0. So if you get that as a possible answer, you know you have to reject it, because the log of 0, again, is never defined, no matter what the base is. So in this case, again, I could take the log, use the change of base formula and use base 10. But again, because we have 8 and 16, I'm going to do it the same way as I did the first one.